Welcome to Systems of Linear Equations solved with elimination or addition method. Here's my first example. As you recall, there are three methods that you could use to apply to solve a system. The first one was graphing, and that's where you graph each line and find the point of intersection. The second one was substitution, and that is where one of the equations has either the x or the y by itself. And the third one is this one, and it's called elimination. With elimination method, you need to make sure that your equations are in alignment. What this means is that your x's are under the x's, your y's are under the y's, your equal signs are also aligned, and then on the other side you have the numbers that don't have x's or y's also one under the other. Once you ensure that the equations are aligned, you are going to add like terms vertically. So you're going to be adding x's together, you're going to be adding the y's together, and you're going to be adding the numbers that come after the equal sign also, in the hopes that either the x's or the y's will cancel or get eliminated. So when you add your blue circle, you're going to have 7x. When you add your green circle, which has negative 3y and positive 3y, you actually have 0. They cancel, and that's exactly what you wanted. Then your equal sign, and negative 18 plus negative 3 is negative 21. Now this is a simple equation. To solve for x, simply divide both sides by 7, and your x is negative 3. Keep in mind that's just half of your answer. You still have to find y. To find y, you will use either the first or the second equation. Replace x with this negative 3 that you just found and get y by itself, hence you're solving for y. I'm just going to go ahead and use the first equation. The first equation was 3x minus 3y equals negative 18. I will replace x with negative 3, so that's 3 times negative 3 minus 3y equals negative 18. 3 times negative 3 is negative 9, minus 3y equals negative 18. Next step to solve here will be to take the negative 9 and add it to negative 18. So 9 changes the sign because you're moving it after the equal sign. So negative 3y equals, these two will make me negative 9, and then you divide both sides by negative 3 to get y equals positive 3. If you were asked to write this answer as a point, you would write negative 3, which is your x, that comes first, and positive 3, that's your y, it comes second. Make sure that you check your work. I'm not going to for the sake of time, but it's always a good idea to check your work when it comes to systems. Here's your second example. Keep in mind that you have to make sure that your equations are in alignment. X's are under x's, y's are under y's, your equal signs, and then the numbers without any x's or y's are on the other side. If that's the case, we can go ahead and add the x's together. So combine like terms here, then add the y's together, and then after the equal sign, we'll add the numbers together. Well, the first yellow circle where I have my x's, that's negative 1x and the positive 3x, which together will make me a 2x. The second yellow circle where I have 4y and negative 2y, if you add them, you get positive 2y, and then your equal sign, and then the negative 20 after the equal sign. Well, the problem with this is neither the x's nor the y's got eliminated, which is the whole point of the elimination method. So as of right now, your system is not ready for elimination. When your system is not ready for elimination, one or sometimes both of the equations will need adjustments. So what you need to think about is, let's say x's. Here you have a 3 next to the x at the bottom, and next to the x on the top you have -1. What types of numbers would cancel at addition? Well, the two opposite numbers would cancel. For example, 3 and -3, or 4 and -4. When you add them, they cancel. Right now you have 3 and -1. So if only you had a -3 here, at addition, you will cancel the x's. Another way to think about it is looking at the y's. As of right now, the top has a 4, the bottom has a -2. But what if you had a 4 and a -4, for example? So you can think of the x's, you could think of the y's, it really doesn't matter. But I want to demonstrate with both. So the top equation has a -1 next to x, and I want that -1 to be a -3 so that it cancels with the 3 in the second equation. To create a -3 out of the existing -1, I can simply multiply it by 3. The trick is you have to multiply all 3 terms by that 3. So the top equation becomes -3x, positive 12y, and -45. The bottom equation stays exactly the same, nothing changes there. And look, if you start adding the terms, these x's will get eliminated, and that's exactly what you wanted. Now, alternatively, instead of multiplying the top equation by 3, you could multiply the bottom equation by 2. And if you do that, the bottom equation will become 6x minus 4y equals -10. So this is not going to be part of your system anymore. The green equation will be. And when you're adding these y's, they will get eliminated. It's up to you whether you choose to eliminate the x's or you choose to eliminate the y's. You do not have to do both. Only eliminate one of the variables. I'm going to go ahead and keep this system and go on with eliminating the x's, but feel free to eliminate the y's. Okay, so let's go ahead and add vertically. X's cancel. The 12y and -2y will make me a 10y. And after the equal sign, you have -50. To solve this for y, you divide both sides by 10. Y is -5. Use this -5 to find x. I'll go ahead and plug that -5 in place of y in the first equation. So the first equation was -x plus 4y equals -15, and y is -5. -x plus 4 times -5 equals -15. -x minus 20 equals -15. Let's go ahead and move the 20 by adding it. -x equals +5. And now to get the x by itself, you have to divide by this -1. So x is -5. There is your solution, and your point would be -5, -5. Again, keep in mind that it's probably a good idea to check. Here's the last and final example when it comes to elimination. You're welcome to try to add the x's, they will not cancel, and then the y's will not cancel as is. So as of right now, elimination will not work. You need to adjust. Well, I'm going to go ahead and work on adjusting the x's. Feel free to adjust the y's. So and in the top equation, I have -3 next to the x, and in the bottom, I have a 2. Keep in mind, I need those numbers to be exactly the same, but one needs to be positive and one needs to be negative, which that is the case already, but the numbers are completely different. So I need to create a brand new number next to the x on the top and next to the x on the bottom so that they cancel. Well, I'm going to go ahead and multiply the top equation by 2, which will create me a -6 next to this x. And I'm going to multiply the bottom equation by 3, which will create a positive 6 next to this x. So here we go. The top equation now is negative 6x plus 12y equals negative 2. And the bottom equation is 6x plus 15y equals negative 9. I'm going to go ahead and cancel the x's. Next to the y's, I will now have 12 plus 15, which is 27. Y equals negative 11, which makes my y to be a negative 11 over 27, and that's okay. Sometimes you get a fraction. It is going to make it a little harder to find x because now you have to plug in this negative 11 over 27 into one of the equations for y to find that x. I will use the top equation, which originally was negative 3x plus 6y equals negative 1. So y is this fraction, negative 3x plus 6 times negative 11 over 27 equals negative 1. Negative 3x, to multiply the 6 by the fraction, I'll place it over 1. On the top, you're going to have negative 66 over 27 on the bottom equals negative 1. I will go ahead and remove the fractions by multiplying everything by that 27. So the 27's where the fraction was cancel, leaving you with negative 81x minus 66 equals negative 27. Let's go ahead and move the negative 66 by making it positive 66. Negative 81x equals 39, and that means x is 39 over negative 81. I believe this can be simplified by dividing the top and the bottom by 3, because 39 is divisible by 3, and that's as 13. And then 81 is divisible by 3, and that's negative 27. So your final answer, your point is negative 13 over 27, that's your x, and negative 11 over 27, that is your y.